Well, hello again. Good morning, good afternoon, good evening, wherever it is that you're watching from, whatever time it might be then. It's not now. For me now is 11 a.m., Friday, July 9th, 2021. Thanks for coming and hanging out with me for another live stream for XUnit. Today we are going to do a quick issue review. We did one last time we streamed 3 days ago, so I expect this one to go very quickly. Not too much going on there. I did get a couple things pop into my inbox from the last stream, so we're gonna take a look at those. We're gonna have to make a couple of quick changes to some of the stuff we merged in PRs last week, and then we're gonna jump into Assert.Equivalent. So we'll probably talk a little bit about that before we get there, but. For the moment, let's jump into our browser and let's see. This one I have open over here. It's just one of the emails. The string value supported for inline data. Looks like maybe we have a new one here. Let's pop that up. These are definitely brand new, so we'll take a look at those too. Oh, nope. I was misled. The two that are there are both because of me. Okay, so nothing new here. Analyzer, warn when throws async is not being awaited. Hey, we've all been using, okay, we're loving it. Something I've noticed Junior does, getting started, they forget to wait to start throws async. For example, blah. Is there a chance that XUnit Analyzer can warn about this issue? The example is giving a false positive. Yep, that's a good point. In general, we've tended to shy away from analyzers which are generally useful outside of XUnit on that. Like a general failure to await throws, anything which is async. But in this case, I tend to agree. We should pit of success here and have analyzers for all assertions, all async assertions, to ensure that you are either awaiting them or grabbing the task to use elsewhere. So I'm going to convert this to an issue. I'm not going to say about putting it in the backlog because we don't really have a backlog for the analyzers. Okay, let's create an issue from this discussion. Analyzer warn when async assertions not being awaited stored. Discussed here. Additional notes. I agree that we should have analyzers that inspect all async assertions, not just throws async. And we should check for either await or assignment of the task object into a variable. Throw away so that we know the user has explicitly chosen how to deal with the async assertion. Throwaways are likely to be a bug. Actually, let's not even put there. It's not too hard. Throwaways are likely to be a bug, so maybe this should be an error. If we don't have any, let's see, if we don't have any await or assignment, and a warning if the assignment is to a throwaway variable. Okay, label-wise, this is going to be analyzers, help wanted. Do I think this is a good first issue? I don't. I don't generally think analyzers are good first issues. They're difficult to write correctly, in my opinion. We do have some help from a library from Microsoft that makes them easier, especially easier to test, but still, you really kind of have to understand the code model to do them. It'd be a good first-time issue for someone who understands the code model. Okay, let me just... How does this all look? Discussions op text. The spacing here looks really poor, in my opinion. Don't know why that is. It's kind of like this div, which I'm just going to take away temporarily. Yeah, wow, the formatting inside that div is not great. But I'm going to leave it because that's how it was intended to be, I guess. Or am I? What if we do this? What if we do block quote instead of the div? You get the same benefit and much nicer formatting. Yeah, that's... I feel like I should open an issue on that. Oh, maybe it's just me. What if that goes up there? Yep, I like that too. That looks good. Okay, I'm gonna have to remember that. Okay, that got converted into an issue. So 2344. Let's go back to 2344. And interesting that we don't get a link back. 2346. So we'll go ahead and do that. And we'll mark that as answered. Okay, issue with test fixture reuse clashing on multiple test classes. So I have a test fixture to spin up a sample in-memory web host, which acts as a mock API for integration tests. This works fine when I run each test individually or all tests in the class, but the problem arises when I have multiple test classes using the same fixture, as only one fixture can be active on a given port. So the first class to run steals the port of some of the other classes. Yes, current thought is to have a static counter. I believe you should put all the tests into a test collection and use a collection fixture instead of iClass fixture on the collection class. So the docs would be here, right? Which is going to be sharing context between tests, collection fixtures. Which actually has a sample right there. Okay. I'd be utterly shocked if that did not answer the question. Add Assert.Equivalent. Oh yeah, that's open because that's what we're going to work on later. Okay, so that makes all of this look good. Next, issues. Looks like we've got no new issues that haven't already been dealt with. Alright, so I just add this new one here for 2346. Everything else has got a, it's at least 3 days old. Let's see. Over here to PRs. Everything is old, and I don't want to review any of those today. And no assert PRs, that's fine. Let's move Assert.Equivalent down here. Let's close the docs page. Now, let's do a quick review of the stuff that came in email. So last time we got together, I merged a PR about formatting floats and doubles. And somebody reviewed that after it got merged and said, hey, the links are not right. So here's one example where Tanner came in and said, this should be G9, not G7, and this should be G17, not G19. It sounded to me like that was just confusion, like instead of G9, G17, it went G7, G19, right? Just the digit transposition, which Xcode absolutely says, yep, that's exactly what happened. Xcode also chimed in and says, I don't think we should use R instead of G, which is one of the other things Tanner suggested here. Xcode says, I don't like R because you get different versions for .NET Core and .NET Framework. I would agree with that. The purpose of R is to get a round trippable value. And so, like, you would toString with R if you wanted to send this thing out into the world and then someday later be able to bring it back in and do a float parse or a double parse on it. So that's the purpose of R. And that's why .NET Core and .NET Framework have potentially different versions of these, because what it's really trying to do is give you enough significant digits to actually print that out, print out the entire value so that you got the exact value back in. And we just got a thumbs up from Xcode, who may or may not be watching this stream. It's a very timely thumbs up. So we're going to fix this first. This is a pretty easy fix, right? All I got to do is go search for G7. And this is going to be in the actual asserts and then the argument formatter as well, right? So the assert tests and the argument formatter is where it is. So argument formatter, I just double clicked on this. Why didn't, oh, that did. So this should be G9 and G17, right? And then tests wise, all right, here's our G7, that should be G9. Here's our G17, that should be that. So easy fix, right? So this is a V3 assert tests. V3 assert tests, what I have set up to run. Just go ahead and run these and make sure that these pass. Really no reason not to believe that these wouldn't pass. Except they don't. That's interesting. All right. Expect one, get the other. Why did we expect one to get the other? I mean, I'm going to rebuild everybody? Don't know why that... Yeah, that's weird. All right, let's go look at our tests again. Argument formatter, format float math pi. So that's format. All right, and here's float. Value G9, value G17. And then format MathPy. MathPy 2-string G9, G17. That's nonsensical to me. This is running .NET Framework. Well, let's try .NET Core. It has the exact same failure. I expected 3.14159265, which, by the way, is the correct answer. 3.14159274. I mean, it's easy to believe that this is like a precision problem. But it is also, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 digits. And we had 7, and you can see here 7 was correct before. And also, double isn't causing us trouble, right? These two failures are both for float values. One's in English and one's in French, which is why one has dots and one has commas. So strange, though. Why? String asserts, formatter tests. I mean, that's all expected. You know what? Let's do this. Actually, let's do this. Float pi, although you didn't need to be a const up there. You can be a const down here. Fine. Now you're telling me you can't be a const. I really don't care. This is probably a case of this is actually what's getting stored is not right. Because when we were doing just MathPy 2-string G9, it was taking the double version of MathPy and 2-stringing it with G9. So, yeah, I mean, double obviously has more precision, right? All right, so world makes sense again. All right, always a good reason to run your tests before you commit and push, even though I was 100% sure that was going to be fine. All right, so this is assert, so we need to go into source xunit v3 assert. All right, so we'll grab this. We'll grab this and we'll put this over in dev xunit assert. SDK. I don't know why I was typing CP there. Okay. Let's go over into xunit asserts. All right. And there's our diff. xunit 1822. X precision issue with float, double, and argument formatter. All right, we'll go ahead and push that up into assert. Then we can reset here, do a fetch, and then go grab origin main. All right. And so now we have our submodule and our test. And we'll go ahead and run that again, which should cause a build because the source changed, even though it didn't actually change. And our tests run again. And we'll call that good. Fix precision issue with float, double and argument formatter. Also what I'll call this. We can push that up. All right, and then should get our 2 commits, and then we'll go ahead and close this issue again. All right, so that's good. Here's another one that came in through email. Xcode again. I was attempting to work on a fix for 2232, but after overriding quality comparison, null message sync, and somewhat erratically failing my machine, referring to being unable. So, yes. Is there support anywhere for running v3 into debugger yet? So the answer to that is yes. I'm going to hope that Xcode is watching the stream, and I'll show you how I do this. But, I mean, obviously, if you've watched any of my streams, you've seen me do this before. So one way to do this is, let's say we want to be able to debug this. We just set a debugger breakpoint here. We come up and set this project as our start project, and then just debug it. So one of the values of v3, everybody being a process, is that you actually can just directly debug and launch the process. Now, I'm glad this came up. We've probably seen this on stream before as well. So, like, for example, when we see this stuff, I tend to just turn off breaking for random exceptions. And then we get in here to my breakpoint, and then now I can see what's going on here. Additionally, so you'll see here that we end up running all the tests. Right, so we found 632 test cases. We're going to run them all. And here's skip exception again. We'll leave this one in for the moment, just so that I can demonstrate this. Invalid operation, invalid operation. All right, I've seen enough of this. So we're running all of them. So the other thing we can do is, we know we're running Boolean assert tests, right? So we can come in here and hit the debug settings, which you can do debug. Oh, I thought you could do debug settings here. I guess not. Come in here and do properties, and then go to the debug tab, and then we can launch this with class. That's not what I wanted. With class Boolean asserts tests, right? So now when I launch the debugger, what I should get is much faster because it runs. Oh yeah, it didn't run anything, did it? Boolean asserts tests. That's my class. Oh no, it's Boolean assert tests false. Yeah, this is one of the downsides to using inline stuff, inline classes. Or brain no worky. Need more caffeine. Actually, where is my caffeine? I have no drink here. All right, so you saw that that this popped up real quick now, and you can see we found 4 of 632 test cases, right? So we're just going to skip the rest, and then we run this, and it'll be done. And it's much faster, right? Much faster. Okay, so that's how you do this. So that's how you debug. So now I've shown you all on stream. I need to really be able to sort of illustrate that to Xcode here. So I demonstrated this on the July 9th stream, starting around the 25-minute mark. Note to self, get better time and link. But here's the synopsis. V3 test projects are programs, so they can be debugged, just like programs. Set a breakpoint where you want it. Then choose the test project to debug from the drop-down in the standard toolbar. Let's go take a quick screenshot. All right, let's do a rectangular snip. We'll do like this. All right, and then I'll say this guy right here. Copy. Paste. then you should be able to debug the test assembly. If the can also speed up debugging. Okay. Actually, I'm not going to do this. We don't yet have support for the Visual Studio Test Explorer because we haven't finished V3 support in Runner utility. That means Test Explorer is not usable yet. That said, V3 test projects are programs, so they can be debugged just like programs. Set a breakpoint where you want it, then choose the test project, blah, 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 blah. You can also speed up debugging by choosing just a single test class to run, like. So let's come back here now, and we'll say, we'll put a breakpoint here, right? And then we'll say, properties, we're going to drop this out into its own little floaty window for the moment. All right, so you can say this by setting the debug application arguments. I think that's what I want to say, right? So let's go ahead and close that. So we'll do this. Where's our screenshotter? Do our screenshotter. You could say this. Let's see, where'd my browser go? Yeah, the debug command line options and project settings, like this. You can even specify a single method to run, like this. So that would be this, and this. This would be method. So this is class, and then this is class. All right, so you need to copy that and then throw that here because that was not exactly what I wanted. So then we'll come back here and do this, which is say method dot assert false. All right, let's run this and make sure that it does what we want. And one test, perfect. So then we have that, and then we screenshot this again. All right, where we do this. And we say, hey, well, this is our class. This is our method. And this is our method. I really like how I can't draw, but the thing will smooth out my curves so that it looks like I'm doing stylistic drawing. Thank you, Snip Tool. All right, so that's that. I don't need to say here's the synopsis. That's dumb. This is obviously just me answering the question. Don't yet have support for Visual Studio Test Explorer because of Infinity 3. That means Test Explorer is not yet usable. That said, V2 test project programs so they can be debugged just like programs. Set a breakpoint where you want it, then choose a test project to debug like that. Then you should be able to debug the test assembly. You can also speed up debugging by choosing just a single test class to run through the debug command line option and project settings like this. You can do it like this. One more thing I want to say is you can combine dash class, combine multiple class or dash method command line options. We need to run just a small set of tests, test classes, or test methods. Okay, there we go. So that's that. That's class. Boolean asserts false. Boolean asserts false. Yeah, that's nicely readable when zoomed in, even though it seems kind of small there. It means it's kind of small for you in the stream too. Sorry about that, but like every time, my experience is every time I change this is called the environment font. Every time I change the environment font in Visual Studio, things get weird. And maybe that's superstition from history. Okay, that's that. All right. So assert equivalent. That is where we are going to spend the rest of our day today. And frankly, don't think we're going to finish. Well, we'll see. No changes here. I'm just going to go ahead and run this build in the background. Also going to pop up Ubuntu, which is cold, so it'll take a second to boot here because it's WSL, and I'm already hitting the disk and everything with my other build. So let's go to xunit, and then we'll pull. We'll build. We haven't built here in a while. And we'll go ahead and let those run in the background while we're talking. All right, so assert equivalent. Put a little bit of definition of what I think the assert equivalent should be here, and I'll be honest, I haven't read any of the comments, so we're going to read the comments together. Obviously, this has been something I've been thinking about for a while, right? Because this is a 3-year-old feature request. So what we get today with assert equals is a rather strict equality compare. And what do I mean when I say that? What I mean is we use the system definition for equality for the most part. If you implement I-equatable, which is sort of the preferred way to do it, or I-comparable, which is a less good way to do it, but we can also support that, we'll use that. So how does that work? This class is, I'm going back into the deep recesses of my memory. This class is the equality comparator. It would help. Equality comparer. Yep, there we go. The equality comparer. Oh, Mark, you must be Xcode. Yeah, no problem. Hopefully you saw my little debug demo, but I also just described it in the discussion that you opened. But hopefully my screenshots will illustrate everything necessary to do the debug stuff that you asked in the other issue. And digit transposition, like, I mean, I do that all the time, so I wouldn't even worry about it. So the assert equality compare, like, where do we use this? What we do, where we use this is in the equality asserts, right? So assert.equal, specifically assert.equal of t. When you call assert equal of t without a comparer, then we go get a comparer for you, right? Which is to new up the assert equality comparer. That's pretty much what we do. That's where this comes into play. So what does this thing do? Well, it's got a bunch of logic in it. What it does is it implements this equals function, which is, again, equality compare of t. That's actually the thing we want. So if you've never seen this interface, basically, this is all that matters. Bool equals for x and y. That's it. So our assert equality compare implements I-equality compare of equal of x and y. We throw allow null on there, which, now that I look at their implementation, we might be able to get away with just saying t nullable now, but I don't know for sure. We don't put any constraints on t. I don't think they do either, so I'm not 100% sure if this is just better compiler syntax now. Whereas before we used to have allow null. And frankly, I'm just going to try this and see what happens. See if we can understand if this is just, hey, thanks for newer compiler. Looks like that's the case. Thanks for newer compiler. All right. So if you call this without the mismatch index, actually mismatch index is public. You just call equals t. We just throw away the mismatch index. The reason for the mismatch index is one of the things we do is we will, when you're doing an equality check, we will let you know what index things started to diverge, right? Because when we want to print stuff out, like if you have a really huge list of stuff or a really long string, for example, although we don't use this for strings, but this is in general. You have a really huge list of stuff. So you have 10,000 items in an array. And the items that differ are, like item 8,273. We want to show you a few items before the mismatched items, and a few items after the mismatch. And then tell you where the mismatch happened, rather than saying, here you go, here's 10,000 items and 10,000 items, and they're not equal, and good luck, have fun. Right? That's no fun. All right. So what does this class do by default? It obviously has null check. If your type implements I_equatable of t, we use that. If your type implements I_comparable of t, we will use that and call compare to, and they'll only be equal if compare to is 0. This apparently is, hey, some things you try and do a compare to from x and y, and it throws because they're not comparable, in which case we just kind of keep going. If you implement non-generic I_comparable, we do that, and again, check against 0 and swallow the exceptions. We have specific support for checking dictionaries and sets. We have specific help for things that are enumerable that aren't dictionaries and sets, right? So we handle dictionaries and sets especially. Let's see, we support I_structural equatable, which is kind of interesting. We also do I_equatable of type of t, which I didn't know. I didn't remember until now. I'm kind of curious to see exactly when that came into being, so let's go take a quick journey together. So our build success over here on Ubuntu, that's good. Build success over here on Windows. Let's go ask for no such path, blah, 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 and head. Oh yeah, I have to look at this in assert, don't I? Which means I should be looking at it here. Git blame this, and we will just kind of strip this off. All right, so when did we get I_comparable of type of t? I added that about a year ago, apparently. Okay, I don't remember doing that, but I'm sure it was in relation to some kind of a feature, right? So this commit will probably be the one. B9, well, B9 is really quite a popular one. Okay, let's find out. Git k that. Yeah, that spaces the tab. That doesn't help. We did. What's the one about it? It's on this one. What is this one? That looks like some kind of a bug fix. Nullable reference types root source, otherwise back to C#6. Okay, so that's not really interesting. All right, so it's older than this. This was a spaces to tabs conversion. I should actually be able to do a git log on this file, right? And here it is, actually, right here. Support IEquatable of type of actual and assert.equal. So this is a commit from Hugh Bellamy. That would be why I don't remember implementing it, because I didn't. I just merged it. So let's go ahead and take a look at that commit. Does not reference any particular issue, but it's been in there since 2.3, so it's been in there quite a long time. Okay, 2017. All right, well, good to know. A little exploration together. All right, so back here, all right, so this is our default implementation of equality compare. So there's IEquatable of type of t, IComparable of type of t, and then the last thing we do is object.equals. And a surprising number of stuff falls down into here, right? I mean, we just looked at this list. For things that don't know how to compare themselves and things that don't know how to equate themselves, we get object equals. And the default implementation for object equals, let's see if they talk about it here. True if the objects are considered equal, otherwise false. All right, that sounds like, you know, kind of a cop-out. I get that it's a generic description, but a description of the actual implementation in objects.equals generally is reference equals. Like you'll see that object equals probably just calls reference equals. Well, actually, I mean, this virtual is the one that sort of matters because this one probably calls, you know, object A.equals on object B, right? And then, so for reference types, meaning classes, that means that we end up basically saying, are these references equal? And we have an assert for that. That is called same, and that's in our identity asserts lists. And so for us, assert.same basically just calls object reference equals. So that's the difference between same and equals, in case you ever wondered. Equals does a whole bunch of stuff to try and figure out whether or not, whether we know how to properly compare these things. And if we don't, we'll fall back to what generally amounts to our reference equals, whereas same is always our reference equals. Obviously, same makes no sense for value types, right? Because this is expressed as an object. This is not t. And so same, when you give it value types, like if I were to say assert.same 11, 11, it probably will fail because it's boxing the two 11s separately as different objects. Boxing is the process that's used to take a value type and convert it into a reference type. Unboxing is the opposite, getting the value type back out of the reference type. I would assume it would fail, but it also might succeed because, like, if they're like a true constant, like 11, it might try to optimize the boxing of those things so that those two 11s are the same because it knows it's a constant value of 11 anyway. I don't know. But point is, you can't really rely on that behavior, right? Because the compiler might optimize it out from underneath you anyway. And the just-in-time compiler. All right, so back to our assert.equality compare. That's kind of the implementation. It's interesting. So there's the thing that's probably most interesting to us is this check if enumerables are equal is kind of interesting because, like, for example, what if I pass you an array, right? So inside the array of values, we're going to go ahead and call equals, given the quality compare that is most appropriate for your object, we're going to call that. Dictionaries are going to be much the same, where we would check and make sure every value in dictionary X is also in dictionary Y with an equal value. And then sets obviously are like valueless dictionaries, right? So we're going to make sure that every key in the set is equal. Every value that, or every key that's in the first set needs to be in the second set. And I think that's it. think that's all that matters. Type erased equality compare. I don't remember where this is used. I saw it up there, but I don't remember. This is clearly not me. I would never use I would never use Hungarian notation. So I guarantee I didn't write this. Type erased equality compare is used for structural equatable. Inner compare factory. Oh, okay. So when you new up an assert equality compare object, you can pass an inner comparer to it. Right? So the inner compare factory of this assert equality comparer is used to type erase equality. And so this is structural equatable, which as an interface basically says, are these things equivalent? Right? This is effectively what we're after. But we want to do it in such a way that types aren't required to implement structural equatable against themselves. That said, we definitely want our assert equivalent to obey structurally equatable, because if you implement structural equatable, you should absolutely be usable in other places. So this type erased equality compare is, let's see, what does it do? Delegate checking whether two objects are equal to the assert equality compare, get the best results out of assert equality, use the type to specialize the compare for the objects we're checking. If the objects are the same, great. If not, assume they're objects. More naive than the C# compiler, which tries to see if they share any interfaces, but that's likely overkill here, as assert equality compare object is smart enough. As they initialize and get the equals generic of T. So equals generic of U. Where is U? Oh, it's just right here. I didn't want to use T because I didn't want to lose the T in which they're embedded, I guess. It's fine. Although they don't actually use T here anywhere. So probably unnecessary. Right, so the implementation of equals here basically says, hey, go get equals generic on the type erased equality compare of T. This lazy initialize and cache basically is saying this thing is potentially expensive to make, right? Because it's going to take this inner equality compare, and that thing is expensive to make. And so we want to avoid having to do that, I guess. And so we will go and cache this, easily initialize and cache. Oh, okay, so it's only one of these. I mean, private is another thing I would never do. That's how I know this code isn't mine. All right, so the type erased equality compare might be something we want to lift out when we do our structured equality compare, maybe. So one way, now that I'm looking at the way that assert equality compare works, right, because assert equality compare already obeys structurally equatable, we could implement it. We could give. Yeah, we can't. We can't just add that onto the type. That's not going to work. We want it to basically do the equivalent of this and then provide a default implementation of structurally equatable. As interfaces go, this one doesn't seem super complicated. Given an equality compare, which is a non-generic comparer, give me equals. Interesting that the hash code is based on the equality compare. Huh. So we definitely want to do this. All right. So if we're to start doing things here, let's start doing some stuff. Let's create source x unit v3 asserts equivalent asserts. All right. Then we can come over here. Equivalent asserts. Let's grab this as our opening, because that's generally speaking our opening. Okay. Don't know yet. Don't know yet. Okay. So we're going to want something that looks kind of like public void equivalent. Let's see. This is going to be so we want equivalent of t, which is going to be this. Oh yeah, so I understand now. Like this is what used to be like maybe null, right? Because we didn't know that t could theoretically be. We didn't want to limit t to just classes. Like this old used to not be able to just do this as nullable, but now you can do this as nullable. Expected actual come down here. So you would be this without the nulls, and you're complaining because they don't have docs, which is let's see, what do we say for equal? Verify the two objects are equals using a default comparer. Are equivalent. This comparison is done without regard to type. It only inspects public property and field values of individual equality. Deep equivalence tests, meaning property or field values which are themselves complex types, are supported. Right? So what I mean by deep equivalence tests is we're going to need some tests. So I might as well make the test file. So let's go ahead and add equivalent asserts tests. All right. This might be the easiest thing here, is to then sort of write what our goal is here in forma tests. right? Because I look at tests like documentation of the API that I'm trying to generate, right? All right. Simple types success. Right, so for example, Assert.Equivalent 1212. Simple types failure. Assert.Equivalent 1213. So we want to do record exception. We want to say assert is type equivalent exception, which we don't have yet. So let's go make that. That's going to be in the SDKs folder. Okay. Exceptions. I kind of forgot there's an exceptions folder. Exceptions. Let's go. We'll steal this as our preamble. Equivalent exception. All right. We're going to want indexes. We're not going to use this for strings, though. Expected index, actual index, pointer position. Well, we take strings not because we necessarily use this for strings, although we do, but we use this a lot for other things. Maybe not a lot, but for span asserts, string asserts. So when we compare spans, that also helps us to know what index we're at. And then the pointer position, surprised. Oh, that's the internal one. Yeah. That's not what I meant. Actually, we will use pointer position in some of these from methods. So I guess we'll assume we want some of these things as well. Assert equivalent failure. We're going to want actual index, expected index. Boy, I wonder how much of this, like if I'm just going to like literally copy pasta this, how much of it's going to actually reuse? I don't know. Let's start with the copy pasta. And then maybe we can sort of refactor our way into something else. Also, I'm not a huge fan of, just copying all this stuff over here before I know I actually need it. But we'll figure it out in a minute. Shorten and encode. This is really starting to feel like I'm going to want to, if not derive from this, maybe find some kind of helper. Extract some kind of helper out of all of this. Some Unicode characters this is a save with other encoding. Yes, you should be always saving with UTF-8. Line endings, line feeds. Codings, try get value. Okay, well we're now have basically copied everything but the factory functions, so there's definitely going to be some comes from we're going to definitely want to extract common code, but later. All right, so I want you to be an equivalent exception. Right, and then 12 is going to be EX expected. 13 is going to be EX actual. Not really sure what this message is going to be yet. EX message. Okay, why are these calls bad? Object reference is required for non-static blah 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 int. Object reference is required for Assert.Equivalent int. Maybe null, maybe null. You need to go up here. Object reference is required for the non-static field of Assert.Equivalent. Oh my god. I need that. I knew that. This was probably not the problem. I was probably just being a dumb bee. Okay. So there's simple types. So some other questions. I just got a couple of these tests now to begin with. But some questions that are now occurring to me is, can equivalent compare two compatible but not same type simple types? For example, int and long. Float and I'm not a huge fan of float and double because of precision issues, but right, and then we know we have complex types without structural equatable. We have complex types with structural equatable. So my guess is these are an assert test. We're an assert test, right? One's going to succeed, one's going to fail, because obviously nobody's throwing an equivalent exception here yet. We also need to go back in here and turn off our filter. So yeah, we're not getting our equivalent exception, of course. Let's go ahead and close everything except for these two. Let's put them side by side. Okay. So, you know, is this really where I want to start? Simple types? Complex types? I mean, I could start simple, right? If, you know, expected is not equal to actual, throw new equivalent exception, expected and actual. Okay. Expected may be null here. Means I can't use t and I can't use equals on t and t. Expected is null. Actual is null. Return. Else, if actual is null, but expected isn't null, then you can also throw this. And yet we're still here with expected and actual. So we have to use equals. Expected and actual. I guess that's what we'll use for the moment. That should at least get my test to pass. I don't know if that's the right implementation yet. Assert equal failure, expected 12, actual 13. Indent on this feels strange. Like, I feel like the indent should be over here, you know what I'm saying? Excuse me while I make a different note. Different note for myself. Shouldn't this... Whoa! Okay, regular notepad. Regular notepad, no good. Shouldn't this... Also, whoa, what the hell is going on here? Wow, that was weird. Actually be this. Right? Am I crazy? Yeah, I'm crazy. But also, I feel like that's how that should be. I mean, we're already indenting it here. Why aren't we indenting it all the way over to here? Right? Wonder how many things we're going to break when we do that. It's good times. Okay, stop thinking about this. Move that over there, so it's not even on the taskbar anymore. All right. Anyway, this is what we got for our message. I'm totally okay with this as a message. Wow, it's doing the same bullshit. Oh, wow. That's kind of cool. Yeah, that's kind of cool. Okay. Oh, yeah, that's true. No, not environment helper. Just environment is fine. Actually, let's not do it this way. Let's do it this way. All right. Okay, that looks all right. Curious to go look at my equals tests. Just a fair warning, these are old tests. So I'm not sure that I'm going to love the way that they're implemented. We'll see. Equal success, 42-42. Failure. Assert throws. Yes, I don't like assert throws, but sure, whatever. Comparable. Non-generic, same type, equal. Non-generic, same type, not equal. Oh, so these are the actual not equal tests. Yeah, I definitely don't like the way these tests are structured. I also think I want to call this equivalence assert tests and equivalence asserts. And then equivalence asserts. Where do we have equivalence? Okay. Because these are tests of equivalence. We're also going to do not equivalent at some point. Okay. Simple types success, simple types failure. Equivalent, compare two comparable but not same simple types. That's an excellent question. So that would look like this. Compatible simple types, success. Should be this. So that would be 12 and 12 long. And that's going to fail, right? Oh, it doesn't fail. Because we call equivalent of long. Because of t. And not non-generic. It's an interesting question of, do I need a non-generic version of this? Because if this is just going to be done in the compiler, then I really don't care. I think I really don't care. Because the compiler is going to do that for us. So now we have shallow class. We'll call this public int. Does it still work if you cast both to object? All right, that is a great question, Andreas. So the answer is it fails. And there you go. Should they succeed? So I wonder, does int actually have structurally equatable on it? All right, so int x. I'm going to guess it doesn't. All right, just equatable and comparable, but no structurally equatable. Why? Because it doesn't have structure. So should this work? All right, well, I'm going to leave this here for the moment. Because I think implementing the complex types version Yeah, because I think implementing a complex types version is going to help us out here. Maybe in a particular direction, or maybe not. I don't know. We'll find out. So this needs to be recorded. Then that will be like this, and this will be system.int32, system.int64, system.int32, system.int64. Actually, this one probably will just work. I mean, as we just saw, right? It's going to work coincidentally. Really? Oh, no, that's right. This only shows up in a message. My bad. Oh. Okay, this is not what I expected either. Didn't we, like, literally just see this before? Oh, you know why? The types only show up when the values are the same. That's right. Alright, well, now I feel less excited about this, because it's not different. Alright, coming back to that later. Complex types without structurally equatable. So let's do with complex type, not structural equatable. Success. So this is going to be number 1, right? So this is going to be shallow class. We'll call this shallow. Public int field value. Public string property value. Set. Well, interesting. No code lens for fields. So never really knew that. Don't really use public fields very often. All right. Yeah, new shallow class whose field value is 42 and whose property value is hello world. All right. Actual is a new shallow is the exact same thing. Why would I type it twice? Don't be dumb. Assert.Equivalent. Equivalent. Thank you. Expected and actual. This is going to fail. Oh no, it doesn't. Why doesn't it? Oh. Something I don't know about object equals? Going on here? Or just a straight up class? These should be references. A fact attribute is missing. Oh my god. Yes. Thank you. Forest for the trees. Okay, good. So those things should be equivalent. So we're going to go now and we're going to say what do we want to so like enumerate over public field and properties and validates equivalence. Yeah, so we've got this going here. Something else is, let's see, mixed types we still need, right? We're going to need mismatch in available properties, and what that's going to make me think is there something like Assert.Equivalent xy, where you don't care if y has more values than x, so long as the property values for x, property field values, match up with property field values in y. So that's an open question, I think. So the example of that would be Assert.Equivalent of new x is 42, new x is 42, and y is 2112. Should that succeed? Right? Or if that should succeed, should that be some kind of a flag? Can values come from properties on one side and fields on the other? So an example of that would be, and the reason I ask this one is because I foresee that this anonymous object syntax is going to be how people want to use this. New my class where my class x is a field. All right, because anonymous, actually I don't know what anonymous types do. Our x is new, x is 42. So the shape of x is anonymous, is an int of x. Yeah, that's not helpful. Because I don't know whether that's a field or a property. Anyway. All right, because I absolutely see people wanting to do this on the expected side. Anyway, so there's that stuff. Let me come back to that. So here we have case of, custom class. And everything looks okay. So we want to enumerate over the public fields and properties and validate equivalence. So expected. Well, yeah, expected fields is expected get type get fields. I think by default it's going to get me public fields, although apparently I'm not allowed to call that version. Apparently I'm not allowed to call get fields at all. Get runtime fields. All the fields defined on a type. That doesn't say public. It just says all of them. All right, field info has a getter which is just get value. Okay. Where F is public. Okay. Time, okay, runtime fields, they're public. Expected properties. I think what I want to do here is I want to save this, and then I want to do select. Given a field, I want field.getValue. Okay, what's your problem? Type argument 4, blah, 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 cannot be inferred from usage. All right, well, what do you want? You want T results. So this is going to be an action. This is going to be a func of object to object. Right? You don't know what F is. Runtime fields is a field info. Okay, I clearly have done the wrong thing to select. Okay, T source, T result. Hello. So this is an object. Nullability doesn't match. Object, right? Fun. Okay. I think what I actually want out of this, though, is I want a name. Probably easier to do this before I have IntelliSense. Name is f.name. And the getter is f.getValue. And then suddenly this is not this anymore. But can you figure that out? No. Func object. Right? Func object. Probably better to use a cast anyway. So this is now a list of name and getter. Then should be able to concat that with something and then to-list it. So my concat is going to be another collection, right? So then that's going to be expected get type then runtime properties, where the property is public. Can't read, I guess. I don't see anything about visibility. Nothing about visibility. How weird. How come get method isn't available? Get value. Turns the property value. Oh, actually, that's fine. Get value will work. Exact same thing as the other things using. That's fine. Okay. Readable property. Select. New. Name is pName. And the getter is a func of object. Object. You get value. So this is the expected getters. All right, I can simplify this a little bit. Expected fields is something. Expected properties is something. Alright, and then the expected getters is expected fields concatenated with expected properties, list, property getters, field getters. We need this stuff again as well. Yes, you guys need semicolons. I'm going to just copy this whole thing and just change F's to P's. I feel like I'm going to end up moving that into some kind of a helper function. I'm about to do it again. All right. So then we've got field getters and property getters. We're going to merge them all together. What happens if you have a field and a property of the same name? You really can't, right? You really can't. I think what I want to do here then is this. Call you G for getter. All right, that'll get me a dictionary of string and func object. Okay. Yeah, this is definitely needs to be a helper. Potential for wanting to cache this stuff too. Get getters. Type and then return a dictionary of string to func of object. All right. So this, all of this comes over here. Field getters. And this is type. This is property getters. I forgot to use a rename on this one. This is type. And then we just return this. All right. All right. Expected getters. Get type getters for. Oh, I see part of my problem here with needing to use object. These need to be two different types. Yeah, I know, you're upset. We'll get back to docking you in a minute, don't worry. This is not a get type, this is a type of. Functional getters is get type getters, type of T2. None of this should break any of the other stuff that I had here, but this no longer has to be like this, and I'm curious what happens when I do this. Okay. Okay, we haven't done anything with any of this stuff yet, so it makes sense we haven't broken anything yet. So my first test, because we don't know exactly what the answers to these questions are at the moment, my first test is to say if expected getters dot keys not equal to actual getters dot keys. Let's go take a look at keys. Keys is key collection. Key collection is collection, enumerable, read-only collection, collection. So it does not necessarily define quotability. But this is the equivalent of what we want, which is if keys don't line up, then expected key, expected getters, keys. That'll be a string, right? Yeah, okay. Not actual getters, keys contains the expected key. And we need to throw some kind of exception here, which I don't really want to throw equivalent exception because it's not an equivalent failure. At the moment, it's going to be an argument exception. Value expected key is not available in expected is not available in value list from actual. And then here I kind of want string join actual getters keys select okay. I feel like this is an error on the actual parameter. That is ridiculous. Ridiculously long message? Sure. Well, it's actual key list. No, it's not quite so ridiculous. Okay. None of that should have impacted any of our tests yet. We still just have an equivalent failure because we haven't actually done the actual check yet. Now I'm for eaching again. One thing I haven't done here yet. Haven't checked for overflow of keys in actual but not expected. I'm going to leave that untested for the moment because I don't have a test for it anyway. But I'm going to leave myself a note. Okay, so for every expected key and the expected getter's key, maybe I should do this in that loop. Yeah, let's do this in that loop. If not actual getters, target value, expected key out var actual getter. All right, now I have the getter. I should say expected is expected getters sub expected key. Let's do this instead. All right. Oh, this is assert. I really can't do that here, can I? Never mind. Let's do it this then. This way then. And I don't want to use that actual value. Okay. It's fine. Okay. Expected value is going to be expected value is going to be KVP value from expected. All right, because I get the property given expected. Expected. Call you inner value. It's not the value of expected, it's the value of the property of the field. Expected member value. Let's call it that. Yep. Actual member value is actual getter from actual. And then we will move this up here. which is expected member value, actual member value. And then to do on this, formatting and indexing, just a note for myself. I don't know what's going to happen here because we're still using equals. Oh, this is now failing, right? Simple types. Because we now have simple types. Should equivalent be implemented for simple types? So we already looked. We know int, for example, does not have structurally equatable because it's not structurally equatable. My guess is what's happening is we get here. Right, we have no getters and setters for simple types failure, right? And so it does the empty loop, doesn't find any differences, and says, yep, we're good to go. We didn't actually step in there. And that bugs me. Well, our getters are called max value and min value. Oh, we need to get not static as well. So that's interesting. Not static. Okay. Now we're empty. So that's kind of what I expected. Because we're empty, expected getters count as 0. And do this. Again, don't necessarily believe that that's correct, but okay. That makes our simple types pass again. Our complex types, shallow, not structural, success. What about anonymous? I'm expecting that to work. It does. I am also curious. Okay, I don't care yet, because what's the type? It's 32. 32. 32. 32. Telling me I need shallow class. Shallow class. Telling me I need caching, right? That's what you're telling me. All right, this should be our anonymous type. Yep, okay. Anonymous type of int. So anonymous types appear to be. Are you fucking kidding me? Property getters. Okay, so those are our properties, not fields. Okay, that answers that question. And we'll make all of our breakpoints go away. Okay. All right. Complex type shallow, not structurally equatable, success. Anonymous type shallow, failure. This is when we're going to get into what should the formatting of this stuff look like. And the answer to that question is, I don't know. Let's see what it comes out as. I don't hate that. I think I'd like to see indexes. Like I'd like to see pointers. The interesting thing is going to be what happens when you have a bunch of these things, right? A is 1, B is 1, C is 1, D is 1, E is 1, F is 1. Right? A is 1. Hang on. Put that so totally in the wrong place. This looks bigger than 50 characters, right? Yep, quite a bit bigger than 50 characters. So we're not doing any string truncation right now. This message could be better. So we're going to go ahead and put those back in line. This message could be better. Yeah, I took it away, didn't I? So what if I do this? Mismatch on value x. And this is x is 42. This is x is 2112. All right. Should be close. We just don't have the mismatch on value x yet. See, look at this. This is like so difficult to decode. I really want to fix this so that all this shit gets indented too. All right, mismatch on value x. So what that means is in order to get that to do that, I need to say here I need to pass kvp.key. Okay, so I'm already starting to believe that some of this stuff is not, like I probably made a mistake. Doing all of that. All right, let's just add these also aren't formatted correctly. I don't know if I want to call it key. It's called value name. Member name? Member name. Member X. That's it. Okay. Okay. Synonymous types are shallow. Complex types shallow. Let's do complex type shell failure. Just to see what that looks like. Failure. 2112. You shouldn't be object anymore. You, on the other hand, absolutely should be object. Field value. Alright, let's see what's going on here. One o'clock. So these are all relying on Assert actual expected exception to do all the formatting, right? Actual title, expected title. Interesting that these are all private sets. I feel like you could just get rid of that, but then I'm trying to think about minimum compiler value. As an example. Feature out variable declaration is not available in C#6. Okay, well that's not this. We can definitely fix this. As long as we're here. These all have formatting issues as well. I need those in a sec. So that looks good. Actual title, expected title, message. Everybody there looks okay. Okay. So like the simple type name, purchase string. So I was using argument format or format. So that means we're definitely going to run into what happens if I have more than 6, 7, 8 of these things. Interesting that sorry about that. Okay, well, I think I'm going to have to come back to that in a minute. But I am having a thought about what about arbitrarily long types argument, formatter, format. Well, I wonder if what I should do is, instead of passing this, like what I should do is maybe have it be like this. Right? This would sort of solve that problem, right? You won't see the whole object, but you will guarantee to see the value that was wrong. Oh. Those should now fail, right? Okay. Okay, leave myself a note for that later. Let's do some anonymous type. Void anonymous type. Let's do compatible anonymous type. Shallow success. We can't really do compatible anonymous types, can we? Problem with anonymous types. My guess is that if I do this, these are the same anonymous type. Int x, int y. Int, well, int y, int x, maybe not. I don't know. See what happens. So this is backwards now. Okay. Starting to want to embed these now. Simple type. Identical type, success. Identical type, failure. Compatible types. Should this work? We'll come back to that. Alright, public, class, anonymous, types. This is going to be identical type. Identical type, identical type. Compatible types. Complex types. Identical type. Deep. Deep failure. Ooh. This is on x.y. Okay, I expect that one to fail. So when we have equivalent for a simple type, we want to do deep. Like I want to recurse here, right? That's really what it amounts to. I think what I want is static equivalent, static void, equivalent t1, t2, t1 expected, t2 actual, which by the way I should name those types correctly as t expected and t actual. And learn to use the rename. Formatted correctly. I don't know if I could actually move that if down. It feels like I can't. Oh. Probably gonna let me do that? Yeah, this is also string prefix. Okay, out variable declaration not allowed. This is an out var actual getter. Right. Func of object. Object actual getter. And of course, that needs to also be surrounded with the nullable. Null literal, possible, null literal. Yeah. So it knows it's not null there. Knows it's not null there. Okay. Good. Everybody compiles. All the reference types not available in C#6. Where did I screw up? Oh yeah, I knew that. Okay. I think what I want is I want all of this to come down here. And then I want you to be equivalent, expected, actual. I guess you could be string empty. Whoops, that's not it either. Actually, that is, I do want that. Prefix is definitely going to go there. Prefix is definitely going to go there. Oh. That's going to be weird. Yeah, so we're counting on this to escape the recursion based on the simple type up here. So when you're a complex type, you compare your lists, we get a value, and then we recurse in. So here, what we want to do is we want to say prefix. That means we only have one version of the exception. I think anybody else, see, nobody else should be using this, right? Prefix. Who's the last person using this? Right, you have to be in parentheses. Okay. Mismatch on member XY, we got mismatch on a member X. We got an expected Y. Oh. We want to start test 74. Well, this is our complex one. Should be X dot Y. Typical type deep failure. So let's debug just this one. All right. This is on equivalence, asserts, tests, equivalent. Anonymous types. All right. Unknown command line option. Member, not member. Method. Okay, one test. Failing test. Fantastic. Let's debug it by stopping here. Okay, so our expected is x equals y equals 42, right? X equals y equals 2112. So our prefix right now should be empty because that's where we started. Which means prefix dot will also be empty. So we're not that, we're not that. We have getters, one of each. So we're not that. So for each of the getters, that's our KVP. So our KVP is X. We found an actual getter, so we get the value, we get the actual value. So that's Y is 42 and Y is 2112. Okay, good. Prefix dot plus KVP key. So that should push us up into this loop with a prefix of X. Okay, good. So prefix dot is now X dot. Okay, good. There's those. We're in T expected. What is T expected? Why is that an object? Oh, can't be type of T expected. Oh, it can't be type of T expected. These actually can't and probably shouldn't be generic at all, right? These should probably just be object. And we should be using get type. Because of course when I call it, yeah. These should just be straight up objects. Okay, expected actual prefix. Expected get type. Actual get type. We know neither of those are null at that point, right? Because of all these checks. That's going to be the problem. Okay. I should pass now. Very good, very good. Parameter count mismatch. Invoke check. Equivalence asserts. 93. 93. KVP value with expected. Actual getter with actual. So the value is the func. The actual getter is the func. Which test is failing? Shallow, not structurally equatable. Complex types. You know what? That was dumb. Like that's sitting right there for me to copy pasta and debug. Okay. So prefix is empty. So our getters are 2, our getters are 2. Field value and property value. Okay. This is for field value. We have one of those. So expected is a shallow class. Actual is a shallow class. So we got 42 and 42. 42 is an int, and actual is an int, and prefix and KVP key, so we go to field value. All right, so we loop. So prefix is field value, prefix dot is field value dot. We don't have that. We should have no getters and no getters, right? They are equal, and we should return. So now that's property value. Hello world and hello world. Come through here with property value. Aha, strings have getters. Strings have getters. This is not a good enough type. Good enough check for simple type. I get it now. Oh. Yeah, I get it now. All right, I'm going to ponder this. I need a momentary break. I am absolutely missing my caffeine, and I need a quick power break. Anyway, so I'll be back in a couple of minutes. Just hang tight. Okay, I return. Oh, that's not what I wanted. That's what I wanted. Hit the right button. Okay. Yeah. This is clearly not the right check for a simple type. It is an interesting thought on simple types. I mean, obviously what we could do is we could actually just check for value types. We can do it like this. And I think we can get rid of this to do for now. And basically say if you're a value type or you're a string, then what we could do is we could just say expected dot equals actual. Done with you. That should solve that. Okay. I guess that's a better. Null equivalence first. This comment goes down there. Okay. What are you trying to get me to do here? In mind the variable declaration. Can't be done. Thanks for asking though. Make sure our non-nullable still compiles as well. Okay. What do we not have in terms of tests? So let's roll up anonymous and complex for a moment. Are we happy with simple types? Still have this open question. And a failure equivalent if we're going to do that. Since it's a simple type, there's no depth. Okay, so I'm going to call simple types done. Anonymous, identical type, shallow success, shallow failure, deep success. We need deep failure, so we have all those. I kind of feel like I want to simplify the names of these things. So now we need compatible anonymous types deep. Success and failure. Z is 42, and then X is new, where Y is 2112. Right? Expect that to work. If you type enough curly braces. We'll grab that and uncomment this. And you're going to be 2600 and 2112. So we expected 2600, but we got 2112. And this is on x.y. Okay. So here we have complex types. Shallow, not structural, equatable. Identical. Identical, shallow, not structurally equatable. It's really starting to become interesting, isn't there? A lot of variables to throw in here. Success and failure. Complex types compatible. Let's do this. Except let's not call these field values now. Let's call these value 1, value 2, value 1, value 2. It's going to be on value 1. Yeah, you use setter. Okay, we expect these to work, right? So, I forgot to change the message here. Okay, so those all work. Okay. One thing I would also like to do is mixed types. We don't have any deep here yet, so also do that. Public decimal value 3. public shallow class shallow deep class 2. Public decimal value 3 get set. Public shallow class shallow. Of course, I misspelled structural. Let's copy complex types. Identical, shallow. Start rolling some of this stuff up. You're done, you're done, you're done, you're done, you're done. Compatible. Oops, these are identical deep. That's what I meant. Identical deep. Okay. Sure, whatever. Okay, so that works. Grab these for expected and actual. And then we will say value 1 is 2600. 2600. Value, let's see, we want shallow dot value 1. Okay, good. Compatible deep, not structurally equatable. This should be deep class 2, deep class 2. Come back, deep class 2. Come back, Scooby-Doo, where are you? Okay. Complex types, without structurally equatable mixed types, mismatch on unavailable properties. We haven't done that. We have done mixed. We have done mixed types, although we have not done complex and anonymous. Which we're just going to do one set of these. Doesn't have to get too crazy, right? Although we'll do expected to be new deep class value 3 of 2112M. And shallow, or new shallow class, value 1 is 42. Value 2 is hello world. Right. Actual will be the same thing. Expected and actual. except no. That should be completely anonymous, right? Yeah. Actually, since I think the common way people are going to use this is like this. Of the expected value. Okay. Might as well put you back here just for fun, right? Just to show that it works. And hello world, we'll change the string this time. We haven't changed the string yet. This is going to be shallow.value2. Hello world. Hello world. Okay. So mismatch in available properties. Actual value can have more mismatched members. Kind of want to have like a strict version and a not so strict version. Okay. Not strict. Was expected to be subset of actual. That should still pass. I convert string to a bool. What? Makes sense. Okay. So let's do it this way. So this would be a success. Failure. That was going to fail. Mm-hmm. Okay. We need some tests around nulls. Something like that up there. Those mismatched members not strict. Mismatched members strict. Not really a success case here. It's really just a failure case. Except we're going to call this like this. This is an argument exception. Seems failure on the caller's part. Actual assertion error. I'm looking at that comment and wondering if that's still true. It feels true. But I don't know. It also feels like passing the wrong value to an assertion of every other assertion in the system throws that assertion's error. Oh. Kind of feel like maybe that's not, shouldn't do this. All right. Let's make another version of equivalent exception. Creates a new instance of the equivalent exception class. When a member is missing, well, problem here is I don't really want expected actual in this case, do I? Oh. What would this look like? String array, about I, enumerable of string. Expected members, I, enumerable, string, actual members. Oh. Yeah, okay. No, I don't think I actually need a parameter name, do I? I think just calling it a expected and actual should be fine. And just go back to my string join. Try to go grab from over here. This crazy string join. This thing. Oh. Oh. Of course, prefix dot is not going to be here. Don't think I can use lambda syntax in C#6. Maybe I can. Oh. It's going to break some things, right? So 298 and 314. 298. Well, it's not quite right. Oh, that's probably not gonna work though. Yeah, there's no way that should work. C#6. Now I don't trust that the lambda stuff is supposed to work either. String interpolation should definitely not work in C#6. Okay. Alright, supposed to be an equivalent exception. I knew that. So you have X, you have X and Y. So there's a shallow failure, let's do a deep failure. X.Y and X.Z. Yeah, of course. do a deep success. Think this is probably good enough. So we have not yet done structurally equatable. What about collections? Arrays. Dictionaries. Sets. So we have stuff to do yet. Answer both of those questions. Currently just bring Mr. Dundas. Okay, yep. I'm willing to just let that go. There's more to do, but well, I've been streaming for 3.5 hours, so I think I'm going to cut it here. We're not going to finish. Maybe this weekend I can finish this up on the stream. Well, I'll finish it up this weekend, probably one way or the other. It's just a question of whether or not I'll stream it or not. So anyway, thanks for hanging out with me today. We've got a decent amount of this stuff done, and that's good. So hopefully we'll be able to finish this up next time we get together. So yeah, see you next time.